So as I mentioned in this pictorial representation, that there will be an input layer, there will be an hidden layer, and there will be a output layer. So what are these layers consist of? These layers will be consisting of different set of neurons or different number of perceptrons, which we call, or we can just call it as a neuron. And these neurons will be activated based on certain inputs provided. And after activation, it will be sending out a signal, or it will be sending an output to this final layer called output layer, which will be generally a softmax function. A softmax function is a mathematical equation which will be aggregating the inputs, or the aggregating the signals incoming to that. See what it will generally do. So if I pass the word think, this it will be splitted into different weights and are connected into the different activated hidden neurons. So these neurons will decide and will send out certain signals with certain amount of weight. Finally, this output layer will aggregate those incoming signals or the weights and predict the final output. So, are we expecting this one and one exactly? Not necessarily, because this output is not 100% ideal output, right? So generally this would be in the form of a probability. It will be in the form of, right, say this will be around zero point 0.8 or 0.9, and same as well here 0.8 or 0.9. So we will be rounding it off at the end. So before that, the probability which is obtained will be a aggregation of all the signals coming from the hidden layer. So there should be some mathematical equation which will be aggregating all the signals corresponding to the particular input, right? So I am going to explain you about the softmax function which will be generally used at the output layer. So this is how a softmax equation or the final activation function would be looking like. So as I mentioned, it will be a aggregation function, right? So what it will do here, you could clearly say it is taking a max off, right? So it will be maxing out the signals approaching to it. So it will basically amplifies the weak signals generated from the hidden layer. So let's take an example, right? Say so okay, I have passed the word think, and now the hidden layer has generated the signals with certain amounts, right? So it has generated in one context as a 0.6%, and in other context 0.7%. Then the output layer will try to maximize those values, or it will try to get the accurate round figure values through this function. So here you could see it is a summation from I equals to 1 to size of the vector, right? The size or the modulus of the vector, the final vector, that is basically the 1 and 0. So the output function will try to maximize us, or tries to round off the values to the 1 or 0 values. So generally we won't get a 0 and 1 exact values, but that would be possible only by this activation function or maximization function. So it will try to maximize the word context values based on this equation. So we have taken a log of probability of WIC and WI. So what are WIC and WI? So where WIC is the context around the word WI. So here the context around the word would be like, if I take a word think, then that would be WI. Then the context around the word would be uh, say therefore and I. So what it will try to do, it will try to capture these details. Okay, we are trying to write a probability function or a conditional probability function where I am trying to see what are the chances of occurrence of that word therefore if the word think has appeared. It will just calculate the conditional probability value in this fashion, right? So given a word think, if think has already appeared, what are the chances that the neighboring word would be therefore? So we will try to take that probability value and we are trying to multiply that with the log value of it, and we are trying to summation over the large number of values or large number of different examples. So we will, as I mentioned, this is just a single sentence example. We will try to uh, input or feed the neural network with many these cases or many such examples where this think word can be appeared as, so that our neural network would be able to predict the preceding or the post word which is where that particular word is present. So that's why we are summationing all those signals, that is the signals coming from the hidden layer after passing with the different set of inputs. Then those summation will aggregate those small amount of weights into a amplified or a round of values. So this log of P and WC when WI has occurred. So this is what the summation of this equation will be yielding it. So at the end, I am taking the maximum value out of it. So then the maximum value would be either 0 or it would be 1. So this is how a optimization function, or also we can call it as a activation function or a softmax function, which is present at the output layer. By this, we have concluded about generation of the word embedding through probabilistic based approach, or we can also call it as shallow network based approach.